Ever mixed salt in water and watched it disappear? Or maybe you've stirred chalk into water and noticed it just clouds up? What's the difference? Today, we're diving into the fascinating world of mixtures, specifically exploring true solutions, suspensions, and something cool in between called colloids. Let's get started. First up, the true solution. This is what happens when you dissolve something like salt, sugar, or in this case, some beautiful blue copper sulfate into water. You stir it up and poof, it seems to vanish. The particles of the solute, that's the stuff being dissolved, break down so small that they spread out completely evenly within the solvent, which is the water. This process is called homogenization. The resulting mixture is perfectly clear, even if it's colored. The solute particles are so tiny, you can't see them even with a powerful microscope. They're smaller than 1 nanometer. If you try to filter this solution through a coffee filter or filter paper, everything will pass right through. Nothing gets left behind. That's the hallmark of a true solution. It's stable. The particles don't settle, and it can't be separated by simple filtration. Now, let's switch gears and talk about the complete opposite: a suspension. Imagine taking some chalk powder, or even just dirt from your garden, and mixing it into a glass of water. You stir and stir, but the particles never truly dissolve. The water becomes cloudy and opaque. You can clearly see the individual particles floating around. These particles are much larger, usually over 1,000 nanometers. What happens if you leave a suspension to sit for a while? Unlike our salt water, the chalk or dirt particles will slowly start to settle at the bottom of the container. This is because they are heavier and aren't chemically bonded with the water, and if you try to filter a suspension, the solid particles are too big to pass through the pores of the filter paper, so you'll collect them as a residue or precipitate, leaving clear water behind. So a suspension is an unstable mixture where particles are visible, they settle over time, and they can be easily separated by filtration. Okay, so we have true solutions where everything disappears and suspensions where particles just float around. But what if there's something in the middle? There is, and it's called a colloidal solution, or simply a colloid. This is where things get really interesting. Think about milk, fog, or even the white of an egg mixed with water. In a colloid, the particles are bigger than those in a true solution, but smaller than those in a suspension. They're typically between 1 and 1,000 nanometers in size. This unique size gives them special properties. They're too small to be seen with the naked eye, but if you shine a beam of light through a colloid, you'll see the light path scatter. This is called the Tyndall effect, and it's a dead giveaway that you're looking at a colloid. You won't see this effect in a true solution. Unlike a suspension, the particles in a colloid don't settle down when you leave them undisturbed. They're kept suspended by the random motion of the solvent molecules bombarding them. And if you try to filter a colloid, the particles are small enough to pass right through a standard filter paper, just like a true solution. Starch mixed in warm water is another great example. It forms a cloudy mixture, but the starch won't settle out. So to recap, we have true solutions with tiny dissolved particles that never settle. We have suspensions with large visible particles that do settle. And right in the middle we have colloids with medium-sized particles that scatter light and don't settle, behaving like a bridge between the other two. Understanding these differences is fundamental to chemistry and explains so many things we see in our daily lives, from the drinks we enjoy to the air we breathe. I hope this helps you see the world around you in a whole new scientific light. If you found this video helpful, please give it a thumbs up and subscribe for more science content. Thanks for watching.